Again, thanks for waiting. Well, my name is Damian. I run Composable Security. We are a security boutique, and we actually have created the first security standard for smart contracts. And we've secured multiple projects, both like DEXs and CEXs, so off-chain and on-chain. And today I'd like to show you our experience that we got from the research, security research for Uniswap v4. And I'd like to show you the architecture of v4. And also, of course, this is security talk, so it will be about security threats in v4. So if you plan to build any hook, because that's the keyword, right? You might find it very useful. So let's start with this simple equation. Who knows the equation? Yeah, everybody, right? So that's Uniswap v2, right? Very successful, very simple project. But it had one huge downside, right? That was the inefficient liquidity. So whenever you put liquidity into v2, it's put on the whole range, right? It's very inefficient, especially for stable coins. And that's why some other projects fill this gap, and for example, Curve, by changing the curve, basically. But so then there was an idea to do the new version that will solve this problem. So that's how v3 was born. And the biggest change in v3 was this concentrated liquidity. So to put it simple, you basically add liquidity to a price range, right? So you don't put it on the whole curve. You define when you put liquidity, when you add liquidity, you define what's the price range you want your liquidity to be used on. However, there was also a downside. So now you cannot really easily represent the liquidity. So you cannot use ERC20 anymore to represent LP token. And that's the change. So now the NFT was your liquidity position token. So let's see what's the, can you see that? Yeah, so it looks good. Let's look at the architecture of v3. So if you have multiple pools, all of them were separate contracts. So you have a factory and you can create a new pool. You simply call create pool function and it deploys a new contract. Then you can do some functions directly on the pools, but the most common functions that you do are swapping and liquidity management, right? So you cannot do it directly on the contract. You have to use some helper. For example, to add some liquidity, you would use a non-fungible position manager, which is official contract by Uniswap. And it's your forwarder to interact with Uniswap v3 pools. So you as user add liquidity through this contract. The contract calls mint function as an example, and the pool calls back with Uniswap v3 mint callback function. And then the non-fungible position manager does all the logic, takes your tokens, put it there, and gives you the NFT that is created when you add the liquidity. And also, when you do a swap, it's very similar. So there's also this callback mechanism. So we also have to use a helper contract, which is called swap router. And that's why, usually when we talk about contracts that call Uniswap pools, we usually call them routers, right? However, after now, it's 3 years, there is still an issue because 90% of pools that are used by anyone, any project, and basically the community are Uniswap v2 pools. This is a bit outdated, but I checked it this morning, and it's still the same. 90% is still Uniswap v2 and not Uniswap v3. So the idea came to create v4, and this is one of the goals of v4, to migrate liquidity providers to v4 from v2. But also, it's even more gas optimized and it's customizable. So you can create a Uniswap v2 pool on Uniswap v4 with the same functionality, same token, like same ERC20 liquidity token. So you can basically create Uniswap v2 on v4, but you can also do a lot of more. And there are some changes, like the first one is transient storage, and that's why Uniswap had to wait to the Denkam upgrade, Denkam hard fork. However, they still haven't released the project, so it's being audited now, and it will be probably released soon. And all the other changes I'm going to show you on the difference to the v3. So first of all, there is this singleton pattern. That means that there is one contract. It's called pool manager contract. And so all pools are within this contract. So when you create a new pool, you basically initialize a new pool within pool manager contract. Then you have this lock mechanism. So it's a bit similar to callback mechanism, but there are some differences. The first difference is that you still need a helper contract. Like we call it pool operator. We don't call it router. We don't call it liquidity manager, and I'll show you why in a second. So the pool operator calls the unlock function on the pool manager. And when you unlock pool manager, you can do multiple operations like minting, burning liquidity, swapping, like doing all of that, like taking a flash loan. But in the end, your balances have to be settled. So you have to, you can think of it like a flash loan. So if you take a flash loan, you take a lot of money, and then you have to pay back, possibly plus premium, right? So it works similar. You unlock the pool manager, do some operations, but in the end, you have to be settled. Like all your balances have to be settled. So the pool operator can be your router, can be your liquidity pool manager, but it can also be totally customizable contract, because the next big thing that comes here are those hooks. So hook contract is a contract that is called by the pool manager in multiple different situations. So there are like operations like initialization. So the first time you create a pool, adding liquidity, removing liquidity, swapping, and donating. And before and after each of these operations, you can call a hook contract. So there is a function for each of that operation that can be called on the hook contract by the pool manager. But the hook can also be a pool operator, right? So you can like start with a pool operator, let's say it's your router, then it calls a pool manager on your behalf, and then calls back the same contract. So you can like keep the state of this whole business flow. So the logic behind the hook functions is very simple. Like each pool has some flags defined, and you define them at the beginning. Like when you initialize the pool, you define those flags. And each flag says that, should I call before swap? Should I call after swap? And if I should, by I mean pool manager, then it will call the hook contract a specific function. Like in this example, it's before swap function. So let's move on to the meat, security threats. So we have identified on our diagram, we have identified some security threats, but I'm going to focus on 6 of them. And we'll start with a very simple one, which is a lack of access control on hook contract. Here's an example of a contract. As you can see, can you see the code from the back? Cool. So I'll describe briefly what it does. This is the before initialize function. So this function is called on the hook contract right before you create a new pool, right? And what it does, it's simply, so it's a full range hook. So this is actually the V2 pool on V4 on Uniswap V4. What it does, it simply says that it will always add liquidity to the full range, but it also creates ERC20 token that tracks your liquidity that you've added to the pool. So you can think of it like it's V2. However, there is no, like the before initialize function have to be it has to be external because it's called by the pool manager. So it's called by different contract, right? So it's external, but there are no modifiers. There is no access control. So why can't you simply call it directly? And what would happen if you call it directly? So here's the code. You call the here's the code. You call the before initialize function directly, not through the pool manager. And you specify like any parameters. It doesn't really matter because what matters is that it will create a new pool token that is this ERC20 that tracks your liquidity and simply override it. Like in this pool info mapping, it will override the token. So now, when somebody tries to remove liquidity from this token, from this pool, sorry, this token should be burned, right? And if you added liquidity, this token was minted for you. So when you remove liquidity, it's burned, so it should work fine. But if you call before initialize again, there is a new ERC20 token, right? So there are no balances. So like everyone has 0 balance. So if you try to burn anything, it will simply revert. So the result is that all those tokens, all the liquidity that people have put into this pool is locked now, right? Nobody can withdraw it. So what's the solution? Very simple. You have a modifier. I called it pool manager only, but it's quite common name for this kind of modifier that allows this function to be called only by the pool manager. Pool manager is one contract. It's like you can hard code this address on particular chain, right? So it's very easy to implement. And if you have that modifier, you simply cannot call it directly anymore. Another thing, very similar. So it's also an unauthorized call, but on the other side of the flow. So this is how unlocking works. You as the user will use some kind of pool operator. And you will execute some like business function, let's say withdraw function. And then pool operator calls unlock on pool manager. And pool manager calls unlock callback. And from now on, pool operator can do whatever they want. As long as in the end the balances are settled. So the one idea, like one way to pass the information from user to the pool manager is to use this data in unlock function. This data is sent back in unlock callback. So like you specify the data that will be managed by pool manager in this unlock callback. So why don't you try, like why can't you simply call this unlock callback function, which is also external because it has to be called by pool manager, but now it's not calling the hook, it's calling back the pool operator, right? Why can't you try to call it directly? Of course, you would have to unlock pool manager by your own, but that's very easy. And then you call unlock callback on pool operator, and you simply change the parameters, right? So, and this is like the solution here is very similar. So like actually it's the same. So you simply check whether the sender that calls unlock callback is the pool manager. So let's move on to something more specific for Uniswap v4. Here's an example of dynamic fee hook. So because this is also one of things that v4 introduces. And again, we have this before initialize function. But as you can see, it's already protected. There is that pool manager only modifier, so you cannot call it directly, right? And what it does, it simply takes the pool key of the pool being initialized and gets the last block number and last price. So then when you do, when you mint some liquidity, so you simply add some liquidity through a liquidity manager, because the hook is also your pool operator. So now you call add liquidity on the pool operator, which is hook. It calls pool manager, and pool manager calls back the same contract, which is both pool operator and hook. So it takes this pool key, right? This is the data that was saved during the initialization, right? So it tries to modify position for a specific pool. But like what happens if you try to create another pool and pass the same hook contract to the new pool. So this is the code that does that. You simply call initialize on pool manager and specify that you want to initialize a pool with some data, and one of the data is the hooks contract. So you're gonna use the same hook contract that was on the previous example. And what happens then? Oh, sorry. As you can see on the left, the pool key storage variable is overridden, right? So now the pool key is different. So the result is very similar to the first case, because now all the liquidity is locked. Because when you try to modify your position, the pool operator will try to do it on a different pool, right? Because the pool key has been changed in this pool operator, which is also a hook. So what's the solution for that? Well, you should either make sure that your hook can be used only by one pool. So you can like simply have some kind of initialized storage variable that you set to true on the first initialization, and then you revert on when you try to initialize a new pool. Or simply you can use mapping so that you can store data for each pool in a separate struct. The next one is sender impersonation, and I also have an example here from some hackathon. And here you can see there is a function, the hook function is after swap. So when you do the swap, when you finish the swap, the pool operator may call this function. And one of the parameters is the sender, right? So you can think like this is the user that makes a call, right? So the idea behind this hook was that they didn't want one person, like one address, to keep too many tokens. So they checked whether the balance of that address was above some threshold, and if it was, they simply reverted, right? However, they took this sender parameter. So let's see what it is actually. So here is the flow of execution. So you are the user. You call the swap function on pool operator. Pool operator calls unlock and then swap on pool manager, and pool manager calls after swap on hook with, and it specifies the sender parameter, which is message sender. So this is actually the pool operator and not the user, right? So the sender is not the user that initiated the operation, but it's the pool operator that calls the pool manager on behalf of the user, right? So how to solve that? Because they still want to achieve that limiting. So there is another parameter called hook data. So when user calls pool operator, the pool operator can take user's address from message sender and save it in a hook data parameter. Then when pool operator calls pool manager, it passes the data, right? So now the hook can have access to the real user that executed this operation. And it's even more interesting when the hook and pool operator is the same contract, right? But there was no impersonation yet. So here it comes. Like, why can't you use some malicious pool operator and make it call pool manager with some like malicious data, right? So you simply change the sender. Now you want to steal some tokens. You want to steal some liquidity from the victim. So you specify that victim is the initiator of the operation. And what would pool manager do? Pool manager has this hook address hard-coded. Not hard-coded, but stored in the storage. So it won't call back the malicious pool operator, but it will call the legitimate hook, right? So what can go wrong? You can simply try to persuade the hook that we are withdrawing tokens from some victim. And if the victim has approved hook, then you can like simply steal the data, the liquidity tokens. And number 5, theft via dynamic fee. So dynamic fee is a new feature. So you can like specify, let's say in before swap, you can calculate the fee based on the volume, based on the user, based on whatever you have access to. And then you update the fee. So you call this update dynamic swap fee on pool manager. Actually, there is one catch. The pool has to have this dynamic fee flag set during the initialization. So if the pool doesn't have this flag set, it will revert because you cannot update dynamic fee, because that particular pool has static fee. So there is one catch, but still, if you have a dynamic fee pool, then you can update it. So what are the balances? Well, there is a limit in Uniswap v4 that the fee cannot be over 100%, right? So the hook can simply say that, okay, you want to swap 10,000 USD to ETH? No worries, but the fee is 10,000 USD, so we have no ETH in return. And that's how it works. Like that's how it can work. So you have to be careful what hooks you use. And of course, simulating transactions is very important. But on the other side, there is so what happens if the fee is actually more than 100%? It will simply revert. So if your calculation function can end up with returning over 100%, your hook will be blocked, like it will be DOSed, okay? Because if you end up in a situation when your hook cannot do any swap, so it cannot update all those parameters that are used to calculate fee, and the current fee is over 100%, you're stuck, right? So this is another issue that you should check. So like best way to do that is to, I guess, fuzz your calculations, or like also write it down in math formulas just to make sure that you do the correct calculations, and then check whether the limits are there. And last but not least, upgradability, right? So this is quite like easy to understand. For some, upgradability is a vulnerability. For others, it's a feature that helps you protect from being hacked, right? And there is no like simple answer whether it's a vulnerability or a feature. But if you see a hook is upgradable, it means that it can change its logic, like in any way. There are some limits. Again, there are those flags. So if there is a flag for specific hook functions, you cannot call another hook functions through the pool manager. But still, like let's say before swap, after swap, these are quite powerful functions. So you as user should be careful of that. And also if you integrate with some hooks, you should also keep that in mind. And yeah, and actually that's the 6 I've chosen for this presentation. Here is the list that what you should do, like the basics, the first things that you should do. And also we've got a bunch of articles from our research about Uniswap v4 security, so you can check out that on our blog. Some examples of malicious hooks, so examples of what you should avoid, hopefully not build. And yeah, and you can like find me there if you have any questions regarding Uniswap v4 in terms of security or security in general. I'm here till the end. So yeah, that's me. Thank you. Are there any questions?
We're a little bit short on time, so we maybe have time for one question.
Just an opinion question.
I can repeat the question. Yeah?
V4 looks complex. Do you foresee more problems than V3 integration?
Okay, so the question was that V4 looks more complex, which is correct. And do I see it like more issues with integration? Well, actually, that's the question I'm asking myself and many people, because like I see like there are more attack vectors. So that's the cost of customization, right? Customizability, right? If you make a project that is very customizable, there are also a lot of different ways to hack it, right? So I believe that what's important now is that you have those good best practices lists for integration. So the checklist that you have to go through and check, and actually that's one of our outcomes from the research in our standard at CSVS. You can find this category for Uniswap v4 hooks. So if you're building a hook, what you should look for, what you should avoid, and that's very well. That's not exactly how to integrate safely, securely, but that's another category for the standard, I guess. So, like somebody has to do the research on that and create that list, and we've done that for hooks. So I guess this is the most important thing now. So you create easy to read materials for developers. All right, like we cannot have any more questions now. So again, if you have more questions, I'm gonna be somewhere here. Thank you again.